Huh. Go. Let's just start it. Alright, let's go.
What's going on, everybody? Noble here with you guys today.
Pendulum problem. I've gone ahead and drawn the figure. We have two masses, M1 and M2. And M1 is attached to a rigid surface with a massless rigid wire of length L1. And mass 2 is attached to mass 1 with a wire of length L2, which is also massless and rigid, which is to say that the lengths L1 and L2 remain constant. The angle of mass 1 is given by the angle theta 1, and the angle of mass 2 is given by the angle theta 2, as shown in the diagram. And gravity is present in the problem. We make the following assumptions. First of all, that these masses are point masses, which is to say that the entire mass is concentrated at its center of gravity, which also says that it has no rotatory inertia about its center of gravity, and that applies to both masses. In addition, the wires or rods, length L1 and L2, are massless, and they're rigid. Their lengths don't change, as we said before, and also the assumption that gravity is present in the problem, which I've indicated with the blue gravity vector. I've gone ahead and added some trigonometric identities that you'll need further on in this problem, just to get that out of the way. That sine squared theta plus cos squared theta is equal to 1, and that sine theta 1 times sine of theta 2 plus cosine of theta 1 times cosine of theta 2 is equal to cosine of theta 1 minus theta 2. So we begin the problem by setting up our kinematic constraints. And I've gone ahead and put an XY coordinate system in this problem, as I've indicated up top. And the origin is where mass 1 is attached to the fixed surface. That is the 0. So each mass is designated by points x1, y1 and x2, y2 respectively. And now the goal is, how can we write x1, y1 and x2 and y2 in terms of the independent degrees of freedom, theta 1 and theta 2. Well, let's have a look at it. So first of all, x1 is equal to L1 times sine of theta 1. And similarly, y1 would be negative, because it's downwards, negative L1 cosine of theta 1. x2 is again L1 sine of theta 1 plus L2 sine of theta 2. And similarly, y2 is equal to minus L1 cosine of theta 1 minus L2 cosine of theta 2. And in order to get the velocities, what we're going to do is just differentiate these with respect to time, such that x1 dot becomes, let's write about this, L1 theta 1 dot cosine of theta 1. Y1 dot will become positive L1 theta 1 dot sine of theta 1. The sign changes because derivative of cosine is negative sine, you remember. And then for here, x2 dot is equal to L1 theta 1 dot cosine of theta 1 plus L2 theta 2 dot